let's go to page 69, and this is chapter 6, and this has to do with quadratic equations. So what is quadratic equation? Quadratic equation is an equation with the second degree, and mostly deal with this when like gravity is involved in physics. That's the most common type of the problem. Now let's go to 6.2 on page 69. Okay, so when do quadratic occurs? Well, when you have the product of the linear factors, like when you have x plus 2 and x plus 3. So when you multiply out, you end up with x squared plus 5x plus 6. Okay, if you're using the Fourier method. So if you use the Fourier method, so it would be x squared plus 3x plus 2x plus 6. Okay. Now one thing you notice that this number came from adding these two numbers over here. So this came from addition, this coefficient. This came from multiplication. Okay, so just be aware. So once you know where this came from, when you're doing the factoring, you can go backward to solve. Okay. So let's go over some examples of how to expand. So let's go to example 1. When you have x minus a minus b times x plus a. So when you're doing the expansion, when you're going to multiply these, okay, normally people will just go and distribute, but this is harder to do. Whenever you have the conjugate, you always look for conjugate first. It will make things a lot easier. So if you were to multiply this first, you're going to get x squared minus a squared. Then after that, you can go and distribute. So when you distribute, you're going to get x cubed minus ax squared minus bx squared. And then when you're done with the first one, you go to the next one. So you minus a squared x minus plus. So become plus a to the 3, become plus a squared b. Okay, so this makes it a lot easier to distribute, and multiply when you multiply the conjugate first. Okay, so now let's go to page 72, and let's go to example. This is example 6-1. So example 6-2, you want to solve the quadratic equation. So there are two different problems. So you got x squared plus 9x plus 18 equal to 0. So you want to go and do factoring. So let's go ahead and do the using the master product. So this number is 9 and this is 18. So actually you have to multiply 1 times 18. So this number, so you want to find a combination so that when you multiply, you get that, and when you add, you get that. And sometimes it's quicker if you just go down the list. Sometimes it takes longer to try to figure out directly. So it's easy, just go 1, 18, 2, 9, 3, 6, and that's it, right? 3 times 6 give you 18, 3 plus 6 give you 9. Okay, so you're going to get x and x, right? First you undo the first terms, so you're going to get plus 3 plus 6, and you can check by multiplying, right? So again, when you add, 3 plus 6 give you 9, 3 times 6 give you 18. So from here, you apply the zero product property. So each of these will equal to, set this equal to 0. So x will equal to negative 3. From here, you're going to get x equal to negative 6. Okay. And you do the same thing for the second one. You have the x squared minus x minus 30 equal to 0. So you can use your master product. So this will give you negative 1, and this will give you negative 30. So again, you want to find a combination so that when you multiply, we give you that. When you add, we give you that. So again, this came from adding, this came from multiplying. Okay. So you can just start with 1 comma negative 30, 2 comma negative 15, 3 comma negative 10, 4 comma 5 comma negative 6, and that's it. Okay. So 5 times negative 6 give you negative 30. 5 plus negative 6 give you negative 1. So first you have to get the x squared, so you're going to get x and x. So you get plus 5 minus 6. So from here, when you set it equal to 0, you're going to get x equal to negative 5. When you set this equal to 0 and you solve, you're going to get x equal to 6. Okay, now on page 73, there are some situations. So on the bottom of page 73, okay, it says equation in which one root is 0. So that's when you don't have the constant term. So when you have the ax squared plus bx equal to 0. When you don't have the c, in this case you can just factor out the x. So you got ax plus b equal to 0. So when you solve, you're going to get x equal to 0. And over here, you're going to get x equal to negative b over a, okay, when you solve. The next one, when you have this form, so when you don't have a c, you're going to have x equal to 0. The next one, when you have this kind of form, so x squared minus a squared equal to 0. This is the difference of square. Difference of square, when you factor, you're going to get conjugates. You're going to get x plus a, x minus a equal to 0. So when you solve, you're going to get x equal to negative a, x equal to positive a. Okay? So there are different forms of equation. Now the next one is a perfect square. When you have x squared plus 2ax plus a squared. So when you have the square in the beginning, square on the end, you want to check see if it's a perfect square. And so you put a square over here, and you can just go backwards. So to get that, you get x, right? So from use this, you get that, right? X squared give you that. From this, you get that. And then you need to multiply to match the middle term. So since this is a plus, you get that, right? So you can multiply. So you're going to get 2 of these, so 2ax. So it match. So once it match means your guess is correct. Okay, so again, when you see the beginning is perfect square, the end is perfect square, you want to try to check if this whole thing is a perfect square, and you do that by see if the middle term match. The middle term would be 2 times this times that. So just multiply these to match the middle term. If they match, that means this is a perfect square. Okay. So let's go to example 6-4. Okay, so the example I, you got 5x squared minus 3x. So in this case, you can just go and factor out the x, right? That's your common factor. So this will equal to x. So when you factor out the x, you get 5x minus 3. Okay, so this is the first case when you don't have a number. Now the second case, you got 4x squared minus 9. So this is a square minus square. So this is a difference of squares when you factor. So you're going to get 2, right? 2 times 2 give you 4. X times x give you x squared. Plus times minus give you minus. 3 times 3 give you 9. Okay. So this breaks down into conjugates. The third one, you have x squared plus 6x plus 9. So you have the perfect square in the beginning, perfect square on the end. So let's go and check, see if this is a perfect square. Okay, so from this, I need to get x, right? X to the second power give you x squared. To get 9, I need to get 3. And since this is a plus, so to get that, I need to get a plus. So check. 2 times 3 times x is 6x, so they match. So yes, so this is indeed is equal to the perfect square. Okay, now the next one, you got 4x squared plus 12x plus 9. So again, this is a perfect square, perfect square, perfect square. So let's go and check see if this is a perfect square. Okay. So to get 4, I need to get 2 square, I get 4. To get this, I get x, right? X squared give you that, right? To get 9, I need to get 3. And since this is a plus, so I need to get plus. Okay? Because to get 9, you can have a negative 3 square, you get 9. Positive 3 square also give you 9. So this one, you want to put, from this, you want to be able to know if it's plus or minus. So to find if it's a plus or minus, you have to check from that. So now you multiply these, right? So 2 times 3 times 2. So 2 times 3 is 6, times 2 is 12, times x is 12x. So again, it matches the middle term, and so this is it. So make sure you kind of able to recognize some of the spatial form. It will help you to factor better and able to solve.